All right, so today we're going to talk about section 4.2, which is on verifying trig expressions. So past couple days we've been working on simplifying trig expressions, and we had some different strategies to do that. So some of them were just breaking things down into sines and cosines, seeing where that gets us, maybe factoring, maybe adding or subtracting with common denominator, kind of working with those things. So another strategy that you can work with is using the conjugate. So we've talked about conjugates before. Given a quantity a plus b, the conjugate is a minus b. So example, what's the conjugate of 1 minus cosine? It's 1 plus cosine. Okay, so when I look at example 1, this would be asking me just to simplify. I already have things in terms of sine and cosine, so I can't break it down anymore that way. This isn't something I can factor. And maybe you could work with fractions, getting a common denominator, but let's see what the conjugate will get us. So maybe if I multiply the second fraction by the conjugate, so 1 plus cosine, whatever you do to the bottom, you have to do the same thing to the top. Okay, so let's multiply this out. So this would be 1 minus sine squared, and then in parentheses 1 plus cosine. And then on the bottom, I'm actually going to do this off to the side because we're going to do some conjugate work often. So we can kind of jump right to the shortcut once I work this out. So if you multiply by the conjugate, 1 times 1 is 1. This is plus cosine, minus cosine, and then this would be minus cosine squared. Well, those cosines in the middle go away, and you're just left with 1 minus cosine squared. Okay, so when you multiply by the conjugate, that's what that will look like. So on the bottom over here, you have 1 minus cosine squared. All right, now that, I mentioned this yesterday, but that should kind of trigger in your mind if you have like a 1 plus or a 1 minus with something squared. That's one of your identities. So I'm going to zoom in on it right now. That's this identity right here. Okay, now it doesn't look exactly the same, so you might have to rearrange it a little bit. So I have 1 minus cosine squared, but if you just subtract cosine squared, I know that's a u, but all the variables are the same, then sine squared equals 1 minus cosine squared. Okay, so we can go back over here and rewrite this as just sine squared. So let me rewrite this. So this is 1 minus sine squared, 1 plus cosine, all over sine squared. Okay, now you have some multiplying, so you can cancel your sine squareds. So now we're left with 1 minus, now that 1 plus cosine is on the top, so I'm just going to write that out. And then look, you have some 1s that you can cancel, and you are just left with cosine. Okay, so that's one way that you can use the conjugate to possibly help you break some things down. All right, I'm going to skip number 2 and go to the new stuff. So proving trig identities, this is what we're going to be working on. So proving or verifying an identity means to show that both sides of the equation are the same. So to prove an identity, simplify one side of the equation until it's equal to the other side of the equation. And then you have some techniques listed, kind of the ones we've talked about already, breaking things down in terms of sine and cosine, factoring, doing, adding, subtracting, multiplying, dividing, whatever, finding common denominator, and using your identities. Okay? Oops. So let's go through a couple examples. We're not going to do all of these. We'll do about half of them and then save the rest for tomorrow. So when we verify, again, we're going to show that one side is equal to the other side. So when I look at the sides of this, I have 1 on the right side. I can't simplify that at all. So my goal is to show that the left side is going to simplify to 1. So at the end, I want 1 equals 1. So use your techniques. So like tangent, cotangent, we can simplify that into sine and cosines. So tangent is sine over cosine. Cotangent is cosine over sine. Okay, my goal is to show that that equals 1. So if I look at simplifying this, well, look, you have sine on top and bottom. You also have cosine on top and bottom. So if everything cancels out, you're just left with 1. And you were trying to show that 1 equals 1, and it does. Okay, so that's all we're doing. You're just verifying. So at the end, put a check mark, show that you did it. That's it. Okay, let's go over to number 2. So we have cosecant, cosine, tangent. So those are all smushed together, so that means multiplying. So let's break everything down into sines and cosines and see if that helps. So cosecant, that's 1 over sine. Cosine is just cosine, but that goes on top. And then tangent is sine over cosine. Okay, our goal here is to show that this all equals 1. So think about what you have. There's a sine on bottom, sine on top. There's also a cosine on top and a cosine on bottom. So when all those go away, you're just left with 1 on the left, 1 on the right. So you proved that those two things were the same. Okay, you verified it. All right, let's go to number 3. So number 3, you have sine cubed plus sine times cosine squared equals sine squared. So we're going to show that everything on the left ends up equaling sine, just sine. So we're thinking simplifying, but we want to get it down to just sine. Okay, so this one is already in terms of sines and cosines, so you can't really do what we did in the other ones. You can't break it down more than that. But think about what we did yesterday. You can maybe factor. So look for a GCF. So in each of these, there is a sine. So let's take out a sine. So that leaves us with sine squared. And then we already have the sine. So then this would be cosine squared. Okay, and we're trying to show that this equals sine. So we're not there yet. Okay, you got sine squared and you have cosine squared. So let's go back to your identities. And it's still that one that's highlighted right there. What does sine squared plus cosine squared equal? Equals 1. So this all just becomes 1. So you have sine times 1. We're trying to show that that equals sine. Well, here you go. Okay, so we verified that by using our identity. So this one we had to factor. Okay, let's do one more and then we're done. So at number 4, we have 1 plus cosine and then 1 minus cosine equals sine squared. So let's show that the left is going to equal sine squared. All right, so again, I'm kind of thinking identities, 1 plus cosine. It's close to these, but these are sine squared, cosine squared. This is not. So maybe let's just multiply, right? Multiply it out. And this is actually what we did way up here, right? Actually the same thing. So when you multiply that out, you get 1 minus cosine squared. Okay, so 1 minus cosine squared. Okay, and that we are trying to show equals sine squared. So now go to your identities. So we already rearranged that first one to be actually what this is, right? 1 minus cosine squared. We said that equals sine squared. Oh, and that's what we were trying to show. Okay, you don't have to simplify it anymore. It's just we got it to what we were trying to prove. Okay, so there is a lesson check, so you can get working on that. There's also the lesson check from yesterday, just simplifying. The one from today, I believe, is only 2 questions, so not super long. We'll go over more of this stuff tomorrow, so come with questions, and we'll go from there. Okay, have a good day.